Hello, good morning to all of you. Today I am going to deliver the second lecture on switchgear and protection. Now, in the last lecture, we discussed the content of our syllabus given by our university for this semester, and also we discussed about what is the expected outcome from our theory course as well as practical course. Now, let us begin with the our syllabus. So today we see the basics of power system protection. So let us see the basics of power system protection. So let me share my screen with all of you. So basics of power system protection. My screen is visible to you. Okay. See. So we know we are using electrical energy in our day-to-day life. Energy is available in nature in forms, various forms. But still, if you compare, most of the time we prefer to use electrical energy to fulfill most of our needs. And this is not a new question to you. These questions you might discuss right from first year. So it is as it is a very convenient form. You can easily transmit. You can easily say convert it from one form to other form very efficiently, very fastly. So it is preferred. It is also say very easily controllable. So that's why we always prefer to electrical energy for our day-to-day need. Then questions arises. So when as we are using electrical energy in our day-to-day requirement, so is it good or not? So answer is, if electricity is a good servant to a good master, it means the person who is going to use it, if that electricity is used by a good master who is a knowledgeable and who knows the basics of rules of electricity, then it is a good servant. It solves our problem, it helps us. But if if anyone handled it casually, then it can create a disaster. There is no any excuse if you are doing something wrong with electricity. There may be a number of fatal accidents occur, say, across the country daily. So that's why you should be very cautious whenever we are going to use electricity for fulfilling the needs of our daily requirement. As it is very convenient form, it is easily controllable, it is easily transmit from one place to another place. So it is very efficient, but at the same time, when we use it, we have to take care that we should handle it with a proper care, proper precaution. So you always, as an electrical engineer, you always remember this thing, as well as you always give the message to other people of society regarding these things. Then say otherwise it's a very dangerous. So power system. Now if you see the power system structure and see this power system is a most complicated man-made network in the world. There is no any such huge network, huge complexity. But see, the beauty of this power system network is it always work in synchronism. Though there are n number of generators at different locations with different ratings, different speed, but all are working when they are working in synchronism all are generating electricity with us, say, same frequency. Then we can transmit that generated power at the generating plant through a thousands of kilometer line up to the point of utilization. And again, it is not at a one uniform voltage level. When we transmit it for getting economical benefit, we transmit it at a higher voltage. Then again at distribution level, we are going to decrease the voltage level from transmission level to 33 kV, 11 kV or 22 kV in some region. So that's why if you see the complete structure of power system, we can categorize it in generally in three areas: generation of electrical energy, transmission of electrical energy, and distribution of electrical energy. And finally, the end customer use it for its purpose, for its application. If it is an industrial customer, big industrial customer, he utilize it at a voltage level of 33 kV, 22 kV or 11 kV. For domestic purpose, generally we use it at a voltage level of 400 volt or 415 volt, single phase or three phase. So this is a briefly say structure of our power system, which is very complicated man-made network. And as an electrical engineer, say we must know the details of this complete system. Because our life, our career is say around this power system itself. Someone may be working in the generating plants, someone you may work in the transmission sector, someone may use say have their career in the distribution sector or anywhere in the system, any industry at a utilization level also. So if you see which are the major component, which are the major elements of our power system. So major elements of power systems are alternators, then transformers, transmission line, bus bar, and from the utility point of view, motors, which are mostly used in the industries for driving as a driving force, mechanical driving force. So these are the major components that we are considered here for providing them protection. So this is a brief idea about the power system. Now then next point is why we need to provide the protection to the power system. Question is why we need to provide protection to the power system. Why it is required? Can anyone tell? So first thing is say our electricity. If you see the scenario or the historical development, then see before 2003, before 2003, there is a monopoly of state electricity board in every state of our country. So there is no any challenge, no any other alternatives, and that's why. So there is no complication. Say competition is there and monopoly is there. So whatever the rate, whatever the service provided by state electricity boards, the customer don't have any choice. But after 2003, after deregulation, Electricity Act 2003 permits private sectors in a generation field, in a distribution field, and that's why that is a major change from 2003 onwards. After this privatization, deregulation, say competition as private companies are entered in the power sector. So obviously, when different power companies when they are working in addition with state electricity board, there is a competition, and when there is a competition now, everyone wants to work efficiently to improve the quality of their supply, to improve the reliability of their supply, and at the same time they want to operate their system economically. So that's why these are the advantages that as an end customer, as a common people, we are getting because of Electricity Act 2003. Otherwise, if there is no alternative, monopoly is there, then whatever the quality of electricity we are getting, whatever the rate imposed by them, we don't have any alternative with us. So now, by considering this thing, as it is a need of our, because there is a lot of competition is there. So every company, it might be a private company or maybe state-run companies. Everyone wants to stand in a market, and to stand in a market, they need a customer, and to get a customers, and customer have a choice from whom they are going to purchase the electricity. And obviously when number of say options are available to the customer will always prefer to go for the better. So then again questions arise, okay, which are the parameters on which basis customer will select the power providing companies. So it is a very common questions. So suppose you are the customer and you want to purchase electricity from company A, company B, company C. Three companies are available in your areas. So at that time, what exercise as an electrical engineer and as a customer, what exercise you have to do? It is quite similar to the things which we consider while purchasing any other things in our daily life. So which are the parameters? So first parameter and most important is the cost, cost of that things. So everyone wants anything with a minimum cost. Secondly, if cost is same, cost is same, then we need better quality, better quality. So combinedly we can say we always need for anything, not only for electricity, we always need good quality at a lower price. Good quality at a lower price. And because of that competition, every company wants to maintain the quality of supply, to maintain the reliability of supply at the minimum cost. Means at the same time they have to maintain the quality, they have to maintain their continuity of supply as well as with a very economic operation. So this is the thing, and to achieve this thing, see, companies are always struggling. And see, if say this is the history why we need to provide protection, then see another things why we need to provide it, because as we see our power system is spread throughout the world. It is spread in thousands of kilometer transmission line. We generate the power at one. If you see only the structure of power system in Maharashtra, major electricity generation is in Vidarbha region. Again, it is in the Nagpur zone, Koradi, Khaparkeda, Chandrapur. That is a major generating pocket. And where we use it, major utilization is in the area of Mumbai, Mumbai suburban, Thane, Nashik, Pune. So we need to transmit power from Chandrapur to Mumbai region. So it may say hundreds kilometers, and it's around 700-kilometer transmission line is required to carry out this. So as this, when we design this power system, say we design it very properly. The calculations are very rigorous. Calculations are there behind every design parts. But still, but still, remember, no one can assure you that our power system should always operate in a healthy condition. Because as we cannot assure that, why we cannot assure? Because though our design is correct, there are such as the power system is exposed to the nature, exposed to the atmospheric condition. So because of that climatical change, just for example, if during a rainy season there is a lightning phenomenon, and we know lightning is a very dangerous for our power system. It creates lot many problems to our power system. So and we cannot avoid it. So because of such natural phenomena like lightning, another thing as it is exposed to the nature. So when there is a thunderstorm, when there is a wind flow very high speed, so and transmission line are exposed to the atmospheric condition. So there is a always possibility of occurring a short circuit between the different conductors on the transmission towers, as well as there might be something wrong from any side. So there is a always possibility of occurring uh, either open circuit or short circuit faults in the system. So now as there is a possibility of occurring some abnormal situation from abnormal situation, maybe because of something going wrong in the system or because of changes in the climatical condition. So natural climate is there. So under such an abnormal condition, say if we are not doing anything, then in under abnormal condition, if you are not taking care, then it will damage the equipments of our power system. And you know, in our power system, what is the cost of our alternator, what is the cost of each transformer which are used in the power system? It is in crores of rupees. So if we are not taking care of our equipment, if you are not taking care of our power complete system during under such abnormal condition, then there is a huge economical loss to our power system. And as it's a very huge economical loss to our power system, it means we cannot fulfill that first criteria and most important criteria in this today's competitive world. Because what we need our operation should be economic. Our operation of power system should be economic. But if we are not taking care of our equipment, then it will damage the equipment and it will extra burden on our power system. Secondly, if your equipment fails due to abnormal condition, then secondly, the supply which is given to the customer is get interrupted, and that's why we cannot maintain the reliability of our system. And thirdly, as the supply to the end customer is get interrupted, is get disconnected because of this abnormal condition, so there is again huge loss of revenue that we will expect. We will get it from the customer if customer gets a continuous electrical supply. So all the essential things that we need in today's competition world to maintain the reliability, to maintain the continuity of supply, to go for economic operation that are not possible if you are not providing the protection to the various parts of our power system. And secondly, and most important, we need to provide the protection to our equipment as well as to the human beings to the working in the power system. Because if you're not taking care of our equipment, there may be so that faults maybe get spread to a more and more area, and it is also dangerous to the persons working with the power system. It may be operator, maybe the lineman, or maybe any engineers working with the power system. Because if you're not taking care of fault, then it gets spread. It may get converted into fire. So there is an economic loss as well as there may be a say death of the human beings working in the power system. So it is very important in both the perspective. So in order to stand us in the market, what we need to go for the economic operation. We need to maintain the reliability. We need to maintain the quality. And to get it, what we need under abnormal condition, we must have to provide protection to the all electrical equipments, all elements of our power system. It is required for the safety of our equipment itself. Safety of our equipment itself, as well as it is also essential for the safety of human beings working with the power system. So this is the basic reason why we need to provide protection to the various parts, various elements of our power system. Then again questions arise, to which part we need to provide a protection and to how much extent we are providing the protection and how we are going to provide the protection. That is nothing but if we get the answer of these three questions, then our complete syllabus is getting covered. So first question is, what is the first question? To which part we need to put the protection? So it is quite similar again. See, one say analogy I am explaining here. So it is quite similar. Protection to the elements of power system is quite similar to the protection provided to the human beings in the society. Now, if you see in our country, there are 130 crore peoples are living. Out of this, there are certain peoples are there to which the government will provide the protection. Provide the protection. Why? Because so why we are need why it is required to provide protection to them. Again, answer is very simple because as these people, there is a threat. There is a threat to their people, to these people, threat to the people. So that's why government will need to provide a protection to them. So for example, again see, if you see in that case, around say 1 lakh or 1.5 lakh people in the society in our country needs to be protected. Now out of this again, we are not giving say similar type of protection to each and everyone. Again we categorize them. So when we are going to provide the protection, so depends upon the importance of that person in the country, importance of that person in the complete system that we need to study. Similarly, when we need to provide a protection to any element in the power system, first we see whether it is a part of protection system. Yes, then we think it first. Second, we have to analyze the function of that part, function of that element in the complete power system, and whether if that element is not working, then what is its consequence, what are its causes, that we have to analyze, and depends upon the role of that power system element in the working of complete power system, we are going to decide to how much extent we need to provide protection to it. Like this, say in our country, highest level protection is given to top 4 5 peoples in the country, like say Prime Minister of India, President of India, say Chief Justice of India, Vice President of India, say Home Minister, or some other important peoples, 2 3 important people to which it is very essential. So because again why it is required, because the people's threat to their lives is comparatively much more, because they are the target of say terrorists, they are the target of some terrorists from other countries or maybe other internal things also are there. So point is that, and the role, prime minister role in key plays a key role in the decision of everything in the country that will happen in the country. It is a policy maker. So that's why the protection level which we need to provide to the prime minister of India is highest level. It is highest level because its role in the complete say day-to-day work in the complete countries, say it's a head of administrative head of our country, so it is elected persons, so his decision is say plays a very key role in the policy making. So that's why we need to provide highest degree protection to the panels. Similarly, in the power system also, the elements which plays a key role, we need to provide more protection. For example, alternators. Alternators in the generating plant is a key role because if alternator fails, generation fails. So no generation is available in the system, then again it's a helpless. So no end customer will get a power. So we need to provide higher in protection to such equipments. Then if it's a motor at utilization level, then comparatively the protection which we are going to provide to that motors in any one of the industries is not similar to the protection that we are going to provide to the power transformer in 400 kV substation, or protection provided to the alternator in any generating plants. It is not similar because the function, the role in the operation of complete power systems is different. So that's by considering that things, we are going to provide the protection. So this is the just simple analogy to the importance of the person, its role in this complete system that we need to consider while deciding the level of protection. Then see, all this protection when we are going to provide it, it is provided with certain things, and it is just similar say to the under abnormal condition. So under normal condition, everything goes in smooth way. Under whenever the abnormal conditions occurs, we need our protection should get activated, and say it should disconnect our faulty parts of the power system from the remaining healthy parts. That is the basic requirement of any protection system. So all these equipments which we are using for switching, say that we say considered under the category of switchgear. All elements. So we can say that switchgear is a combination of electrical disconnect switches, fuses, circuit breakers used to control, protect, isolate electrical equipment. So then again see if we see the protection, there are we can categorize it under two things. So one is apparatus protection, means we are providing the protection to individual apparatus, individual elements, that is a generator protection, transformer protection, transmission line protection, motor protection, then bus bar protection. This is the protection we are providing to the individual apparatus, individual elements of the power system. Then rather than this, there is another type of protection that we call system protection. Means we are providing the protection to the complete system. Anything goes wrong in the system. So for example, in system level, under frequency protection against under frequency, protection against islanding, protection against say reverse power flow. So so these are certain protection which are provided to the complete system by considering the complete system. So we need to study both of these protection, apparatus protection as well as system protection. So when we need to provide protection to any element of a power system, what basic information that we need. So it suppose I want to provide a protection to the transformer, to the alternator, or to the transmission line, or to the induction motor. So what basic knowledge that I must have, that is say equipment to be protected, behavior of that equipment, behavior of that equipment or system, or you can say behavior may say its operation of that equipment under normal condition, under abnormal condition, that we must know, its construction we must know. Then second thing is which are the probable faults that may occur on that equipment or that system. Then protection philosophy or basic terminologies used in the protection system. So that things we must know before going for the design of protection system for any equipment. So this is the basic requirement. Then see what is the objective when we are going to provide a protection to any part of our power system, any part. Then what is our objective? It is same which we seen previously in the first line introduction. So that is to improve the reliability of system, to improve the quality, say reliability of system, and second is to improve the economy of the system. That is the basic objective behind providing the protection to the various elements of our power system. Then second, now questions arise. This is the objective. So what are the essential features? What are the essential features of a good protective system? Means when we say our protective system is a good if it satisfies the n number of essential features, n number of say desirable features. So what are the characteristics, what are the desirable features of our protection system? So desirable qualities of protection system. So very first desirable qualities of protection system is a selectivity. Selectivity, that is discrimination. So very first property, very first essential feature that your protection system must have, that is selectivity. So how we can explain selectivity? Explain selectivity means say, now as we know our power system is spread in a large area. Suppose fault occurs at one location in substation of Shegao city. Then what is expected in the protection system? Whether the relays, whether our electricity is disconnected from say thermal power plant at Paras? No. We expect that whenever the fault occurs at any location, that minimum, the minimum that parts, our protective system should be such that that faulty parts, minimum parts near to that faulty region should get isolated from the remaining healthy system. Means if there is a suppose fault occur in Shegao substation, only that substation part is get isolated from the healthy system. And even if that substation is isolated, then say other parts, suppose there in Shegao there are two substations are there. So then another substation is working properly, and also that substation will provide the electrical energy to the Shegao town. Only that substation part is get disconnected. So that features must our protection system have. It should select the minimum region of our fault, minimum region of our fault, so minimum region of our power system where fault occurs, and that minimum region where fault occurs is get disconnected from the healthy system. That features we call it a selectivity. It should discriminate between the healthy condition and faulty condition, healthy condition and abnormal condition. Second thing, second desirable property is a stability. That is a stability. So it means it should be a stable for through fault. Means same thing. Say when fault occurs in Shegao town, in Shegao substation. So it might be sensed by the another second substation in the Shegao, because when suppose short circuit occurs on this thing, so it get reflected in the system, and say it fault may be sensed by the another substation. But at that time, though it is sensed by another protection, the zone of our power system, but as that fault is out of its protection zone, so that time your protection system for the second substation should not get operate. It should remain stable. So when and when only fault is in our zone, fault is in our zone, then and then only we need our protection system should get operate. So that is ability, we call it the stability of our protection system. Okay. Then third important qualities that our protection system should have, it is speed of operation. Speed of operation. I no need to explain it, because see what is speed, because suppose whenever the fault occurs, what we expect, our protection system should respond it as fast as possible, because otherwise what will happen, if your response is there, but if it is after say 1 hour, 2 hours, or say two delay, then up to that time there should be a large damage to the system, and there is nothing say advantage of providing the protection. So we need our protection system should be as fast as possible. So are you imagine how much is the time of operation of our protection system? So it is in how much time? Okay. So see, it is very less. It is in millisecond. It is in millisecond. Then fourth, desirable qualities. Essential quality of protection system is the sensitivity. Sensitivity means sensitivity. Suppose for example, it's a overload protection we are going to provide, and suppose in the normal condition the rated current of our transformer is say 1000 ampere, and we know generally say 5 to 10% overload is permitted. So above 1000 10% is permitted, it is 1100. So as soon as the current drawn by your transformer is more than 1100, our relay, our protection system must give the signal. It must be sensed by our protection system. That is the sense. So suppose I have a two protection system. In one protection system, for the same transformer whose rating is 1000 ampere, 10% overload is permitted. Means 1100 is a maximum current that we permit. So one protection system provide the protection when current reaches to 1100 itself, and in another system, though it's 1100 but it requires minimum 1150 ampere to get a trip signal. So obviously if you compare it, we can say that system A is more sensitive than system B. Means how much, say, minimum actuating quantity is required to give the trip signal. That is the sensitivity of our system. So the next fifth desirable qualities is a reliability. Reliability, it means say when there is normal operation of relays, normal operation of power system is there, we expect our protection system should remain ideal. It should remain ideal. But when there is something goes wrong, abnormal situation should be there, then we expect our protection system should get activated, and it must activate it. So under fault, our protection system must activate, and when fault occurs, so that protection system made for that particular protection zone should get operate and give the signal accordingly. So trustworthiness of our protection system, that we call as reliability. Means we can say our protection system should be reliable. So it means, so whenever there is a fault occurs, that protection system must operate. So it is there is no confusion between stability and reliability. What is stability? Stability means our protection system should remain stable during normal operation as well as for through fault. Through fault means say fault beyond our zone. Fault beyond our zone. But at the same time, reliability means our protection system must operate when there is a fault within our zone. Within our zone. So that is the difference. Remember, stability and reliability. Then next one, sixth is simplicity. So your system, protection system should not be complicated. Otherwise, it is very difficult to check your protection system itself. Or there is a may possibility of occurring a fault on your protection system itself. And see, if fault occurs on protection system itself, then again it's a question mark. So that's why whenever you design it, you always try to maintain the simplicity of your protection system. It should be very simple so that anyone can understand it, anyone can do the connection as per the requirement. It should not be complicated. And the last and seventh and most important essential features or say desirable features of protection system is it should be a economical. Otherwise, say how it will happen. Suppose your cost of transformer is say 1 crore rupees and you are going to design a protection system whose cost is say around 50 lakh, around 50 lakh. Then though it's a all six qualities are there: selectivity, stability, speed, sensitivity, reliability, simplicity, but still no one is going to implement your protection system because it is not economical. So most important quality, that economy. And by thumb rule, the cost of your protection system should not more than 5% of cost of your equipment. Means if cost of transformer is 1 crore rupees, then you have to design your protection system whose cost should be say less than or up to 5 lakh rupees. 5 lakh rupees. So see, these are the desirable or say essential qualities or features that we expect, that we need in the protection system. So I hope all of you understand these desirable qualities of protection system. Now in the next lecture, we see the simple protection circuits and discuss the various component of the protection circuits and all next part of the circuit in the next lecture. So thank you to all of you for your patience hearing. So thank you.